In the previous video, we learned how to create two-dimension arrays. We discussed two-dimension arrays of integers and doubles. In this video, we will learn, or we will just mention that you can extend the concept of an array of objects in a single, like one-dimension array to the two-dimension array. So now we can go and create two-dimension arrays of type string. So I would say string, square brackets, and then they are called or referred to as temps, and it's a new string of 2 by 2. So this, I know it's an array of 2 by 2. And then what I do is that I go and set each element manually, 0 0 0 1 1 0 1 1 to these m0 m1 m2 m3, and then here I'm trying to print this, what I just did, and if I run it, it's going to give me this array this way. Alright, so again, this is very simple concept, and then you can extend that. You could do this inventory items, for example, and this would be 4 inventory items arranged in a 2 by 2 array. So that's again possible and no problem. We also discussed the concept of the ragged array, and we said that an array could have a two-dimension array is an array of arrays, and that's why each row could be a completely separate array that has different dimensions. So that's why we could have something like this, and if I set it, so let's say here I have 3 rows, 1 2 3 4, then 5 6 7, and then 9 10 11 12. So this means I would have 4 columns, 3 columns, 4 columns. So if I go here and try to access 1 and 2, so 0 1 and then 0 1 2, this would be 7, right? So this is 7. If you try to access the third element, alright, in this case you're going to get an error because the second row, which is indexed by the row number 1, it doesn't have a fourth element, which is indexed by number 3. So that's why it's going to give you an out of bounds exception. However, if you go to the second or the row number 2, in this case you will get 12 for this element. Alright, so as an exercise, what if I want to write an array that is going to print all of these? Alright, so I could go and say for int I is equal to 0, I is less than, and I would like to loop over the rows. So in this case I could say numbers dot length, and this is I plus plus. Then inside this one I can go and say for int j is equal to 0, j is less than, and in this case I cannot use a single value. I cannot say 4 because it will give me an error trying to access numbers of 1 and 4, numbers of 1 and 3. So in this case, what I want to do is to make it adaptive. I want it to match the number of columns for each row. So in this case, I would say numbers of, or sub I, so it's the ith row dot length, and in this case I will want to here I still have to increment j plus plus. I would like to print system.out.println this here, and here let's keep it print and say numbers of I in j plus space, something like this. Alright, let's compile, let's run. So this is what you get, the ragged array. It's 1 2 3 4, 4 columns, then 3 columns, then 4 columns. Alright, so this is how you deal with ragged arrays. Now the last thing we want to cover for this code part is that in Java you don't have to limit yourself to 2 dimensions. Alright, you can think of problems with 3 dimensions. So this is something that you can think of in that way. You have in the first layer, right, You have the first layer, you have an array, two-dimension array with 3 rows and 4 columns. Then you can increment the layer to go to the second layer, which will give you another completely new two-dimensional array with 3 rows, 4 columns, and so on. All right, so you can actually have arrays of higher dimensions, not necessarily 2 dimensions. You can even go from, this is 3 dimensions. You can think of it like, for example, um, trying to interact with 3 dimensional objects. Like, let's say, for example, you're trying to uh, plot the altitude of a mountain, right? So you could break it into layers, and each layer will be showing some kind of a color uh, or a value that shows the altitude, right? And in that case, you could visualize this. You could go even higher than 3 dimensions. You could go 4 dimensions, which would be like an array like this, and then next to it another array like this. So this is array 0. It has 3 dimension array group 1, 2, 3, and keep repeating that as you want. It's going to give you that visualization of 4 dimensional array. I think higher than that is very, very difficult to visualize. Um, but if you find a problem for it, then you know you can use it. Now, how can you define a 3 dimension array in Java? Again, the same approach that we expanded from 1 to 2, you expand the same way to the 3. So you would just add a new pair of square brackets, and then you will need to give that extra dimension in your group. So here I'm defining a 3 dimension array of integers called scores. It's equal to new, and it has 2 by 2 by 3. And what that says is that we have a 2 rows with 2 columns and then 3 layers of these, right? So each layer is a 2 by 2 array, all right? So in this case, I could populate each of these elements. So of course, since I have a third dimension, then in this case, I will need to interact with a third loop to loop over the layers, right? So this is rows, columns, layers. So this means you access the 0th element, so 0, 0, in the 3 layers. So 0, 0, 0, 0, 0, 1, 0, 0, 2. All right, so this means you are filling the 0, 0 element in all of the layers after each other. Then you move to a different row and column, and then you start to go over the layers and so on. So that's how you would do it. And if I run this, you'll get something like that. But then you could, of course, visualize this by printing. Let's say here, you could do it in a good way to visualize it. You could do rows and columns, right? And then every time you cover rows and columns, you would print a new let's give this a try, compile. Because here it's just listing all the elements. We know that we have 2 by 2, right? 2 by 2 by 3, so this means we have a total of 12 elements, right? So in this case, you would need this is 1, 2, 3, 4. These are the 4 columns next to each other. Of course, you need to select 12 next to 15, next to 14, next to 17. So you could mess up with these loops in a way that it actually prints the elements in that way. But here, because we are setting and printing at the same time, it would be easier to create a separate group of 3 dimension arrays to print the array. So this is just a concept. You need to understand that it's there, but you don't really have to focus on this one. We are not going to go to the 3 dimension arrays in this course. The last thing we want to cover is the fact that we were printing, and this is the last slide we're going to explain in this course. And it's funny because this is the first thing we learned about the course, which is the header of the main method, which reads as public static void main string array args. And we know what public means. We know static. We know void method called main string square brackets is an array, and it's called args. So what that really means is that the main method is a method that can accept an array of strings called args. All right, and that array of strings called args is going, where does it come from? Who calls the main method? You call it as you call the code to run. You are actually running the main method. So what that says is that you could actually pass an array of strings to the main method to operate on. All right. So to understand what that means, here is a command line that is we have, and we call it command line because ideally you would deal with something like this. Let's say, so you have a command line. Let's say you have a Java code, so you could call Java the name of the file, whatever that is, right? Test, and then you could actually pass arguments to it. So this way you can actually pass an array of strings. However, we are not dealing with command line. We are dealing with BlueJ, which has a visual interface to it, and that's why we don't have the concept of command line. However, Java actually, like the BlueJ, lets you do that. So here again, we have static void main string args, and then what we are doing inside this main method is basically iterating over the length of the string array, and we are going to print all of these arguments. So for example, here, if I run void main, this is equivalent to the command line dot main, you see? So this is what it's saying here, pass the arguments of the command line. Usually we run it with an empty string because we never operate on the args variable, right? However, this time, let's say we're going to pass names. So we are going to say CS 1440, CS 1440. Let's say here, last lecture, something like that, okay? So if I run this, then what we will see here is that this is printing CS 1440 last lecture. All right, so that is something you can do. You can utilize this. You can use the argument, the args input to operate and use it for your code. One thing that you need to understand is that now, since you understand Java, you know that args doesn't have to be named args, right? It could be command line input, if I want to call it this way. That's a valid name for a string, all right? So I could use this here and here, and it should work, right? So it doesn't have to be called args, but again, this is naming convention. It's the most common name used, so people are familiar with this, so people usually use it. The last thing is that you could actually, and this is something that I'm not going to test you on, you don't need to really focus on, but it's very good to know, is that you could actually have variable argument parameters, all right? Vararg is basically here, you are dealing with variable number uh, of inputs. So in this case, I'm saying int and then dot 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 numbers, and what that means is that um, you could actually get any number of inputs in this case, all right? Um, so you can actually pass any number of inputs. So if we copy this and let's paste that here. Something like this, and system.out.println and call sum of, let's say, 10 and 2. So it's going to be 12, right? Now if I give it 4, it's going to be 16. So here, notice here, nothing controls what the input is. I could add any number of lists. What will happen is that numbers is going to include or consolidate all of these values into a single array of integers this way. And then that array, I can iterate over it and just keep adding the number to accumulator and then print or return that one. So here that gives you flexibility of any number of inputs. You do not have to define that this sum takes two integers int x and int y, and then it adds x and y. You could make it very flexible that it can add any number of inputs, and this way it provides some level of flexibility that can improve your code. So that's something to think about as you create your own code. And that's it for CS 1440, and we're done.